today class for learning related rates.
A 6-foot-tall person is walking towards a 18-foot-tall lamppost at a rate of 4 feet per second. Assume the scenario can be modeled with right triangles. At what rate is the length of the person's shadow changing when the person is 11 feet from the lamppost? First, we have a 6-foot-tall person and an 18-foot-tall lamppost. The distance between the person and the lamppost is equal to x. The shadow created by the person from the lamppost is equal to s. The lamppost, which is h, is equal to 18 feet, and the person, which is l, is equal to 6 feet.
dx over dt is equal to negative 4 feet per second. Dx over dt is the rate at which the person is walking towards the lamppost. The person is moving 4 feet every second. H is the height of the lamppost, which is not changing. It's a constant, which is equal to 18 feet. And L is 6 feet tall, which is equal to the person, which is also not changing. X is on the variable side because X changes. X is the distance from the lamp to the person, which changes as the person walks closer and closer towards the lamppost. S is also a variable. S changes. S is the shadow length. S changes as the person gets closer to the lamppost as well. And ds over dt is also a variable, and that is a variable we are trying to find, and that's the rate at which the shadow length is changing. From the diagram, you can see that it's made up of two triangles. There's a big triangle made up with side h and the other side x plus s. And then within the big triangle, there's a small triangle made up with side L and the other side S. You can set up a ratio between the two triangles to find the missing variable. The two triangles have an equal ratio, so the vertical side of the big triangle H over the horizontal side of the big triangle S plus 8S is equal to the vertical side of the small triangle L over the horizontal side S. You can then, once you have your ratio set up, you can then plug in 18 for H since it's a constant, and you can plug in 6 for L since it's a constant as well. To solve, you can then cross multiply to get rid of the fraction.
On the right side of the equation, you factor in the 6 and you get 6x plus 6s. You then subtract 6s from both sides to get the same variables on each side. Then you divide out the 6 from both sides and you're left with 2s equals x. Then you take the derivative of both sides.
You then substitute in negative 4 for dx over dt, as you can see that they equal each other from the constants chart. Divide by 2 from both sides to get your final answer of ds over dt equals negative 2 feet per second.
When the person is 11 feet from the lamppost, their shadow is changing at negative 2 feet per second.